Gauteng, November 2020, grade 10, maths paper 2. So starting off with question 1. In the diagram below, we've got a kite PQRS, and I have coordinates for P and coordinates for S, and I'm told that PQ is equal to QR and that PS is equal to RS. So I know this, and I know this. Then I'm told that the point Q is such a point that PQ is parallel to the x-axis and that PQ is equal to 5. So this length is 5. And I'm told that RQ is perpendicular to the x-axis. So if this is the case, then that means that this angle here is a right angle. And I'm also told that these diagonals intersect at A. And from my properties of a kite, I know that the long diagonal bisects the short diagonal. So I can say that this line PA is equal to AR. And from my properties of a kite, I also know that this is a 90-degree angle. Okay, so now we can start answering the questions. So for the first one, it says, show that the coordinates of R are 8, 0. Okay, so I definitely know that the y coordinate of R is 0 because it's on the x-axis. So I need to show that the x coordinate of R is 8. Now, since I was told that this RQ is perpendicular to the x-axis, I know that the x value of R and the x value of Q is going to be exactly the same. So when I'm doing my calculations, I can use x of Q instead of using x of R. And I was told that PQ is parallel to the x-axis, which means that the point P and the point Q are going to have the same y value. Okay, so I know that R is definitely some x coordinate and the y coordinate is 0. Then I know that Q is going to have the same x coordinate as R, so I'm going to write x again. But this time, I know that Q has got the same y coordinate as P, so I can write 5. And I was told in the question that P is the point 3, 5. And in the question, I was also told that PQ is 5 units. So I know that the distance of PQ is equal to 5. And if I write out that whole formula, I know that this is going to be the x value of P minus the x value of Q all squared plus the y value of P minus the y value of Q all squared. So I know the ones for P. I know that this is x of P, and I know that this is y of P, and I know that this is y of Q, and the only thing that's going to be left is this x of Q. And since I have it equal to 5, I'm going to be able to solve for this number if I substitute in the rest of the values. So I can now say that 5 is going to be equal to big square root, and I know that x of P is 3, minus x of Q, I don't know yet, that's what I'm trying to find out, all squared, plus the y of P, which is 5, minus the y of Q, which is also 5, and that's squared. So this bracket is going to disappear completely, and the only thing that I'm going to be left with is this minus 3x all squared. Now I want to get rid of the square root sign, so I'm going to square both sides. So I'm going to square this whole thing here, and it's going to get rid of the square root, and I'm going to be left with just this bracket. And then what I do on one side of an equality, I have to do to the other side. So I'm going to square 5, and that's just going to be 25. So I'm applying a squared to both sides. And this is what I'm left with. 25 equals... Then I'm just going to expand this bracket, and I'm going to have 9 minus 6x plus x squared is equal to 25. Then I can take 25 to the other side, and I'm going to have 9 minus 25, which is negative 16. So just rearranging this, I've got positive x minus 6x, 9 minus 25 is negative 16. And now this is equal to 0. And then I factorize, and I'm going to have two brackets like this, and my values are going to be x minus 8 and x plus 2. So that means that x is either equal to positive 8 or x is equal to negative 2. And I can go back to my diagram, and x is clearly not negative. It's here on the right hand side of the y-axis. If x was going to be negative, it would be here. So the x of q and the x of r is positive, and so it must be 8. So I can say, therefore, x of q equals 8, which is also equal to x of r, and therefore r is the point 8, 0. Okay, moving on to the next part. Now question 1.2 asks me to find the coordinates of A. So here's A, and from my properties of a kite, I know that the long diagonal is going to bisect this diagonal, which means that this is equal in length to this, which means that A is the midpoint of this line, PR. And I just found out the coordinates of R, and I was told the coordinates of P, so I can just use the midpoint formula using these two coordinates, and I can find the coordinates of A. So I'm going to write A is midpoint PR, and so A is going to have the coordinates xr plus xp over 2, halfway between the x coordinates, and the yr plus yp over 2, halfway between the y coordinates. And I just found out that x of r was 8, and I was told that x of p is 3 over 2, and y of r was 0, y of p was 5 over 2, and 8 plus 3 is 11, so this one is 11 over 2. And then for 5 plus 0, that's just 5, and this is 5 over 2, and those are my coordinates for A. Right, and then the next part, 1.3. For 1.3, I'm asked to calculate the gradient of SQ, so MSQ. And I found out the coordinates for Q. So remember, we knew that Q would have the same y coordinate as P, so this one is 5. And then we found that the x coordinate for Q, which is also the x coordinate for R, is 8. And I was given the coordinates of S, so that's -1 and -4. And so to find the gradient, I can just use the gradient formula, which is the rise over run. So that's going to be change in y over change in x, which is going to be equal to the y of s minus the y of q divided by x of s minus x of q. Y of s is -1 minus y of q, which is 5, and that's divided by the x of s, which is, this is the y, which is -4. Then x of s is -1, and x of q is 8. So at the top, I'm going to have -9, and at the bottom, I have -9, and so the gradient is just 1. Then next, 1.4. I'm asked to determine the length of PR, so that's just the distance PR. And and I already have the coordinates for P, and we found out the coordinates for R. So this is just going to be applying the distance formula. So this is going to be equal to xp minus xr all squared plus yp minus yr all squared. And I'm going to substitute in the values. So the x value of P is 3, and of R we found to be 8. And then the y values, and R was 0. Then I have 3 minus 8, which is 3 minus 8 is minus 5, and minus 5 squared is 25. And then this one is also 25. And so I have root 50. Okay, and then for the next question, 1.5, we're asked to find the area of the kite. And the formula for the area of a kite is just the product of the diagonals divided by 2. So in the previous part 1.4, we found the length PR. So we already know that PR is equal to root 50, which is 5 root 2. Then we need to find SQ, which we can do using the distance formula. So my distance SQ is equal to the square root XS minus XQ all squared plus YS minus YQ all squared. And I just substitute in the values. So I know that x of s is minus 1, and x of q we found to be 8. And the y of s is minus 4, and the y of q was the same as the y of p, which is 5. And minus 1 minus 8 is 9. So this is 9 squared, which is 81. Plus 9 squared again, and then we have 81 plus 81, which is 162, and the square root of 162 we get to be 9 root 2. Okay, then the area is the product of the diagonals, so it's this one that we just found out, SQ, times the one we had before, and that is divided by 2. And so our final answer will be 45 units squared, because we're talking about area. Then on to question 1.6. We're asked to show that PR is perpendicular to QS, and we can do that by comparing the gradients, because we know that the gradients of perpendicular lines are the negative inverse of each other. So let's first find the gradient of QS. So MQS is the rise over run, so it's going to be the change in y over the change in x. And that's going to be the y value of q minus the y value of s. So y of q is 5, and minus the y value of s. And then the x value of q was 8 minus the negative x value of s. These are the other way around. This one is the y value is minus 4 and the x value is minus 1. And I get 9 over 9, which is 1. Then I want the gradient of PR, which is again equal to the change in y over the change in x. And that's going to be the y value of p minus the y value of r. So the y of p was 5 minus y of r is 0. And then the x value of p is 3 minus the x value of r, which is 8. and that comes to be 5 over negative 5, and that's negative 1. And so we can see that the gradients are the negative inverse of each other, so we can say that MQS times MPR equals negative 1. Therefore, QS is perpendicular to PR. And then the final part of this question, 1.7, is to show that PSR, this one, is an isosceles triangle. Alright, so that means that these opposite sides must be equal. So we can find out the length of those sides by doing the distance formula again. So we want the distance PS, and that's going to be xp minus xs squared plus yp minus ys squared. And I'm going to substitute in the values. So xp was 3, and that's minus xs, which is minus 1, all squared, and the y of p was 5, minus the y of s, which was negative 4. And then these negative signs are going to become positive. So I'm going to have 3 plus 1 in the first bracket, which is 4, squared is 16. And then the next one is going to be 5 plus 4, which is 9 squared, and that's 81. And so I have the square root of 87. And I'm going to do the same for the other line, which is SR. So okay, so this one's also equal to root 87, so I can say that SR is equal in length to PS. Therefore, PSR is isos triangle.